Class, good evening. So, some the forms in inverse trigonometry which I have to do. Now, the first form is sine inverse 1 by x is cosec inverse x. Now, here x is greater than or equals to 1, x is less than or equals to minus 1. Second is you have cos inverse 1 by x is sec inverse x. X is greater than or equals to 1, x is less than minus 1. And third is tan inverse 1 by x is cot inverse x. X is greater than 0. So this is the first set. Now here you have to prove, I will prove first one. So I will put x equals to cosec theta. Now you have sine inverse of 1 by cosec theta. This is sine inverse of sine theta. This is theta. This is cosec inverse x. As you know, cosec inverse domain is what? Cosec inverse theta is x and x is greater than 1, x is less than or equals to minus 1. So we have first case sine inverse 1 by x is cosec inverse x, x is greater than or equals to 1, x is less than minus 1. Cos inverse minus x is sec inverse x, x is greater than or equals to 1, x is less than minus 1 equals to minus 1. Tan inverse x is cot inverse x, x is greater than 0. Now the second one, the second case is you have sine inverse minus x is minus sine inverse x. You have x lying between minus 1 to 1. You have tan inverse minus x is minus tan inverse x. X belongs to R. And cosec inverse minus x is equals to minus cosec inverse x. The x lies between x is greater than or equals to 1 and x is less than or equals to minus 1. Now to prove it, you have put sine inverse minus x equals to theta minus x equals to sine theta, x equals to minus sine theta. Now this means x equals to minus sine theta. So you have this is sine of minus theta. So sine inverse x is equals to minus theta. This is sine inverse minus x. So sine inverse minus x equals to minus sine inverse x. So this is the second case to solve this concept. Now similarly, the third case is cos inverse minus x is pi minus cos inverse x. X lies between minus 1 to 1. Sec inverse minus x is pi minus sec inverse x. X is greater than or equals to 1, x is less than or equals to minus 1. And cot inverse minus x equals to pi minus cot inverse x. X belongs to R. Now you have let cos inverse minus x equals to theta, as we have done before. Minus x is cos theta, x is minus cos theta. This is cos of pi minus theta. As you know, cos of pi minus theta is minus cos theta. Pi minus theta is cos inverse x. Minus theta is cos inverse x minus pi. Theta is what? Cos inverse minus x is pi minus cos inverse x. Now, in the same way, you have four set of form, that is tan inverse of x. No, sine inverse x plus cos inverse x equals to pi by 2. X belongs to minus 1 to 1. Tan inverse x plus cot inverse x equals to pi by 2. X belongs to R. And cosec inverse x plus sec inverse x equals to pi by 2. X is greater than 1, x is less than minus 1. Now here you have put sine inverse x equals to theta. X is sine theta, which is cos of pi by 2 minus theta. So you have pi by 2 minus theta is cos inverse x. Now adding sine inverse x plus cos inverse x, you have sine inverse x plus cos inverse x equals to pi by 2. So you have this fourth constant. Now as far as come to fifth and sixth, fifth one says that tan inverse x plus tan inverse y equals to tan inverse of x plus y upon 1 minus xy. Xy is less than 1, and tan inverse x minus tan inverse y is tan inverse of x minus y upon 1 plus xy, xy greater than minus 1. Now, to prove this, you'll write let tan inverse x equals to alpha, tan inverse y equals to beta. Now, I will take up only these cases, xy less than 1, xy greater than minus 1. Other cases we can do respectively when we do some more questions. So, you have this. Now, you know tan of alpha plus beta is tan alpha plus tan beta upon 1 minus tan alpha tan beta. Now tan alpha is x, this is y upon 1 minus xy. So alpha plus beta is tan inverse of x plus y upon 1 minus xy. Now alpha is tan inverse x plus tan inverse y. This is tan inverse of x plus y upon 1 minus xy. So you have fifth set of the form. So the last set is, this is 2 tan inverse x equals to sine inverse of 2x upon 1 plus x square, x lying between minus 1 and 1. 2 tan inverse x is cos inverse of 1 minus x square upon 1 plus x square, x is greater than or equals to 0, and 2 tan inverse x equals to tan inverse of 2x upon 1 minus x square, of course x lying between minus 1 and 1. Now, first one is easy, you take right hand side. Now right hand side is sine inverse of 2x upon 1 plus x square. You put x equals to tan theta. So this is sine inverse of 2 tan theta upon 1 plus tan square theta. This is sine inverse of sine 2 theta. This is 2 theta, and this is 2 tan inverse x. So that's the proof of this also. So all these 18 formulas I am going to dictate you. The first one is sine inverse 1 by x is cosec inverse x. X is greater than or equals to 1, x is less than or equals to minus 1. Cos inverse 1 by x is sec inverse x. X is greater than or equals to 1, x is less than or equals to minus 1. Tan inverse of 1 by x is cot inverse x. X is greater than 0. That is the first one. Now second one. Second one is sine inverse minus x is minus sine inverse x. X belongs to closed interval minus 1 to 1. Cos inverse minus, no, you have tan inverse minus x is minus tan inverse x. X belongs to R. And cosec inverse minus x is minus cosec inverse x. X is greater than or equals to 1, x is less than or equals to minus 1. Now third one, cos inverse minus x is pi minus cos inverse x. X belongs to minus 1 to 1. Sec inverse minus x is pi minus sec inverse x. You have x is greater than or equals to 1, x is less than or equals to minus 1. And tan and cot inverse minus x is pi minus cot inverse x. X belongs to pi. The fourth set is sine inverse x plus cos inverse x is pi by 2. X belongs to minus 1 to 1 closed interval. Tan inverse x plus cot inverse x is pi by 2. X belongs to R. And third is sec inverse x plus cosec inverse x is again pi by 2. That's x is greater than or equals to 1, x is less than or equals to minus 1. fifth set, tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy less than 1. Tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus xy greater than or equals to minus 1. And same, it's sixth set you have written. Thank you class. So I will do some more problems in next class.